Alisya. Hi, my name is Dalila. Hi, my name is ILMUNA. Hello, my name is SAFIYYAH.
Hi, my name is SIRRAH. In this video, we will test Newton's law inclined place to friction. Before that, I'm going to tell you a bit about this topic. Inclined place is a flat surface tilted at an angle to the horizontal. When an object is placed on an inclined place, its weight, which acts straight down due to gravity, can be broken into two components. One that acts perpendicular to the surface and one that acts parallel, pulling the object down to the slope. We'll also apply second Newton's law to calculate acceleration based on the angle and the friction involved. Newton's second law enables us to compare the result of the same force exerted on objects on different mass. Let's see what happened to SAFIYYAH and ILMUNA.
One day, ILMUNA and SAFIYYAH went to the postal office to post some goods for her friends.
Muna, thank you for coming with me to the postal office. I want to give the shoes to my friend.
Oh, no worries. Oh, by the way, how much does the box weigh?
Around 2 kilo.
Oh.
My God, it's let down. Muna, did you see it? We just let it yesterday.
Yeah, inclined with friction, right?
That's right.
Why not you calculate about them?
Let's go. So let's see the calculation.
From the situation, this is the free body diagram. So we can assume that the F is 10n, the theta is 20 degrees. So first, we have to find the Wy. Wy is equals to mg cos theta. Then we got 16.43. So next is we can find the Wx using the mg sin theta, and F, friction force, using mu r. So mu is 1/3 that given, and r is equals to Wy. So to find the acceleration, we have to find the total of Fx. Total of Fx is when Wx plus with F friction minus with force. Then we can get the total F. After that, we can find the acceleration using formula F equals to ma. So from the calculation, we can get total F equals to 2.84. Then to find the A, we have to divide 2.84 with 2, which is the mass. That's all.
Oh, that's how we find the acceleration.
Why not we try to pull the box? We can find how much the force to overcome the friction.
But how?
I have tried in my bag.
Let's use it.
So let's see the calculation for pull-up scenario.
So this is the free body diagram for the pull-up scenario. As you can see, the acceleration was towards the force applied because SAFIYYAH pulled the box upward. So in order to find the force applied, we just assume the coefficient of friction is 1/3 and the theta is 20. So to find friction force, it is F equals to mu r. We can get the r from the formula r equals to mg cos theta. So from that formula, we get 18.42. So from the value of r, we insert into formula F. So for friction, we get 6.14. sum of Fx is equals to 0. So, sum of Fx is force applied minus friction force minus Wx. Wx is mg sin theta. So, from this formula, we just insert the value we calculated before. F is unknown, minus friction force which is 6.14, minus Wx which is mg sin theta. So, for the force applied, we get 12.84 Newton. That's all. Bye!
The conclusion we can take from this video is that Newton's law and the concept of inclined plane with friction are not just theories. They can be applied in our everyday life. By understanding how forces work on a surface, we can calculate how much force is truly needed to move an object safely and efficiently. This knowledge is useful in real-life situations, like using ramps, moving heavy boxes, and designing roads, and other tools that involve inclined surface. In short, physics help us solve real problems with smarter and safer solutions.
So, from this scene, we can conclude that Newton's law, inclined plane with friction, can be applied in our daily life.